In September 1859, something extraordinary happened. Scientists observed the first confirmed, powerful solar flare. The sun, in a sudden and dramatic event, unleashed massive energy. Radiation, plasma, and unimaginable forces erupted into space. It seemed distant, 93 million miles away. Surely, such an event couldn't affect life on Earth. But only hours later, the impact became terrifyingly clear. Telegraph systems across Europe and North America began to fail. Some telegraph lines sparked, igniting fires and spreading chaos. People realized the sun wasn't just a source of warmth and light. It could also be a harbinger of destruction. Scientists later named this event the Carrington Effect. The good news? It happened in the 19th century. The world then wasn't as dependent on technology as today. The bad news? Such solar storms might happen again, and worse. Experts are warning of a potential catastrophe in 2025. The sun could release another massive coronal mass ejection. This is no ordinary event, it's a colossal storm of plasma. Billions of tons of charged particles could be hurled toward Earth. This plasma cloud travels through space at staggering speeds. In just 15 hours, the first wave could reach our planet. As it moves, it gathers and amplifies charged particles. By the time it collides with Earth, its force is unstoppable. The first casualty would be Earth's upper atmosphere. The storm heats the atmosphere, making it expand and thicken. Satellites, vital for modern communication, would be thrown off course. GPS systems would glitch, and satellite communications would fail. The destruction doesn't stop there. Solar particles could penetrate power grids worldwide. Transformers, power stations, and electrical networks might collapse. Entire cities could go dark in a chain reaction of failures. No internet. No phones. No social networks. Society, as we know it, could come to a grinding halt. Large companies would face ruin, and economies could crumble. But the effects go deeper than convenience or commerce. Water pumping stations rely on electricity to function. Without power, water would stop flowing into homes. Supermarkets would empty, and food supply chains would falter. Imagine a prolonged solar storm disrupting food production. Modern tractors, linked to GPS systems, might be rendered useless. Farmers wouldn't be able to plant or harvest crops efficiently. Over time, supermarket shelves would grow bare. The oceans wouldn't be safe either. Ships navigate using satellite systems to determine their positions. Without these systems, vessels might drift aimlessly or get lost. Even wildlife wouldn't escape unscathed. Whales and migratory birds use Earth's magnetic field to navigate. Magnetic storms could disorient them, causing chaos in the natural world. And then there are the satellites we rely on so heavily. The iconic Hubble Space Telescope might fail earlier than expected. The thickened atmosphere increases drag, pulling satellites from orbit. This isn't a hypothetical scenario, it's already happened. On March 13, 1989, the Sun unleashed a geomagnetic superstorm. Days earlier, a coronal mass ejection the size of 36 Earths erupted. Traveling at over 1 million miles per hour, it struck our planet. The impact was awe-inspiring and devastating. Brilliant auroras lit up skies across the globe. But beneath the beauty, chaos brewed. Satellites malfunctioned, and power grids buckled under the strain. In Canada, 6 million people lost electricity for 9 hours. A nuclear power plant in New Jersey suffered transformer damage. If such storms were to occur today, the damage would be unthinkable. With power grids and communication networks so interconnected, even a single powerful storm could have global repercussions. And the danger isn't limited to coronal mass ejections. The sun's magnetic fields twist and snap like tangled wires. When they tear, they release energy in events called solar flares. Solar flares are bursts of electromagnetic radiation. In mere minutes, their energy reaches Earth at the speed of light. Though our atmosphere shields us from most harm, strong flares can still disrupt radio signals and satellites. Another threat comes from solar radiation storms. These storms consist of high-energy particles moving nearly at light speed. While Earth's magnetic field protects the surface, these storms endanger astronauts and high-altitude flights. Despite these dangers, solar storms bring fleeting beauty. The charged particles create spectacular auroras in polar regions. But these mesmerizing lights are a stark reminder of the sun's power. As we approach 2025, the stakes couldn't be higher. Scientists are racing to study solar activity and predict storms. Perhaps one day, protective technology could shield our fragile systems. If Earth's magnetic shield were ever to fail entirely, our planet might become as desolate as Mars. The Sun, with all its life-giving energy, remains a double-edged sword.